Okay, welcome. Welcome to Colorado State University's 5.3 megawatt solar plant. We're going to give you a virtual tour today since in these crazy times we can't give you a real one. So what do we have here? These are solar panels. This is a panel. Within these panels there's these little cells, and as sunshine hits these cells, the electrons bounce around inside those cells, creates current. These little wires take that current away and we collect it, and voila, we have electricity. So out here in this field, 5.3 megawatts, how big is that? Well, these panels that you see here, there's 23,000 of these panels on this site, each quietly making electricity. We installed these panels 10 years ago in a project through a third-party developer. So Colorado State University gets this beautiful power plant without having to put money on the table. And we can talk more about that. If you're interested, contact us at Colorado State. So these 23,000 panels we have out here cover 30 acres of land. It was an unused horse pasture, so it wasn't high value land, but that is one area reason that solar isn't the right answer for every application. Some places land is too valuable. There's a lot of work going on how to make solar and ag work together, and we're doing some research right here at Colorado State University. Now, each year, these 23,000 panels produce 8.5 million kilowatt hours of electricity. That's enough to power about 1,000 homes in the city of Fort Collins. The solar array, the solar panels themselves make electricity that's DC electricity, like what comes out of a battery. What comes out of your plug in your house is AC electricity. So these inverters behind me humming away are changing the electricity from DC to AC. This is the one thing that's kind of noisy and might be annoying if you wanted to put it in your community. But you heard me speaking back at the gate. You don't have to go very many rows of solar panels away to get away from this noise altogether. So as long as we put these inverters in the middle of the array, we're not going to bother any of our neighbors. We're here in the phase 1 section of our solar array. This plant was actually built in 2 phases. We built the first phase is 2 megawatts, covers 15 acres, and it's a tracking array. You can see I'm actually facing south right now, and these panels are tilted over to the west because it's late in the afternoon. So these trackers spend the night flat like a table, and then in the morning when the sun wakes up, they come and go all the way to the east. And then throughout the day, they track, and now they're almost all the way to the west. And then when the sun sets, they'll go back to that flat nighttime stow position and start over again in the morning. And by tracking like that, they get about 19% more electricity than the panels we saw earlier that are tilted at a fixed 25 degrees. So how do all these panels move throughout the day? Well, you see these channels here and these channels here. This is a gearbox. And a few rows that way, there's a motor. And on this whole 15 acres, there's only 8 motors that move this entire array. So this one section here, when that motor moves, this channel turns, which turns this gearbox, which turns this array. And you can see from the photo that there's just this whole line of these pretty much as far as the eye can see. And it just, again, works all beautifully and silently and helps us follow the sun throughout the day. This is phase 2 of our solar system out here. This was built a year after phase 1. Phase 1 is the tracking panels that follow the sun throughout the day. This part of the array is fixed tilt, fixed at about a 25 degree tilt from the horizon. Now, what's really interesting is in solar, the most optimum tilt is an angle that's equal to your latitude. And here in Colorado, that would be about 40 degrees. So these collectors should be a lot steeper. There's a couple reasons why they're not. One is, if we make them steeper, they make longer shadows and we have to space them farther apart. If they're steeper, they catch more wind, and then therefore we need more steel to hold them down. And also the last reason is, when they're flatter and the sun is higher in the sky in the summertime, they produce more of their electricity in the summer and less in the winter. And the utilities in Colorado actually value electricity more in the summertime than the wintertime. So we get lots of benefits about them being a little flatter than what's an optimal tilt.